You should be seeing PowerPoint at this point.
Yep.
Yep. Awesome. Well, certainly, keep try to keep the windows going here. Let me know if you have questions. Raise a hand. Butt in. Try to pause at various different points of time to see if you have questions, and we'll address those questions as they come up. I have another slide at the end with a couple of links or some references that you might find valuable, and I've got my email and LinkedIn at the end as well. But if you want to send me email, feel free. If you want to connect with me on LinkedIn, feel free to do that as well. Try to be as not super active on LinkedIn, but I try to post some content or things that I find relevant, some events. I'll mention one at the end here that we have coming up, but just try to, anything that I find valuable in this realm, happy to, I post out there and happy to have you kind of track along with that. My current role, just maybe as an update, I know I've presented at SQL Saturdays in Madison there over the years past. I currently lead a team of what we call Cloud Solution Architects, or CSAs. In our newly formed, we reorged in the beginning of our fiscal year, so last July. I am now in what's referred to as the manufacturing operating unit. So we're a national-based unit, still cover the same geographical areas I had before, but I lead a team now of data and AI architects, and we in the CSU was what we call it, the Customer Success Unit, where our cloud solution architects sit. We work with customers, really in the sense of helping them understand and apply best practices, patterns, and so on with our technologies in Azure and with SQL Server to ensure that they're successful with these capabilities. So it gives me an opportunity to see a variety of scenarios and what customers are doing, and also be closely tied in with our product engineering folks to help understand their direction and what they're doing with these capabilities. So I'm excited to go through as we've kind of progressed Azure Synapse from when it was first announced at Ignite in 2019 to a lot of our customers and everyone trying to get access to it, and kind of slow going there and having it in public preview and continue to progress the scenario here. It's been really exciting to follow the journey that we have here with Azure Synapse. So to level set a little as we get started here, we refer to Azure Synapse Analytics, and I think was already mentioned in the meeting here, that it is an evolution of Azure SQL Data Warehouse. And I will kind of throw a few ideas out there for you to keep in mind as we go through the discussion here over the next hour or so. But one of the things that Azure Synapse Analytics is designed to do is to unify various different scenarios or workloads that call for both data warehousing and big data analytics. If you think back several years, big data analytics was kind of driven, I shouldn't say driven, but many of those scenarios or workloads went to Hadoop. Then we started building data lakes in Hadoop, and now with the advancements in the public cloud, you see a lot of these data lakes being built in the public cloud because we can separate storage from the compute. Keeping that in mind, and that evolution of Synapse, Azure Synapse Analytics and SQL Data Warehouse. SQL Data Warehouse is a MPP architecture, in contrast to SQL Server, which is an SMP. So SQL Server SMP is symmetrical multiprocessing, more of it as a scale-up approach. And Azure SQL Data Warehouse as an MPP, or massively parallel processing, as a scale-out approach. And that'll be important, especially some of the questions that we started with around, well, which approach might you take for your current data warehouse when you think about moving to Azure? And I'll talk through some of that, because even though we share the name, we share many of the characteristics and patterns that you can think of from a SQL Server perspective. There are differences. In some cases, they're slight. In other cases, they'll be a little bit more dramatic when you think about architectural approach to doing data warehousing with an MPP versus an SMP. And the technology continues to grow and evolve, and the options we have continue to evolve with that as well. So what we say today may evolve and be different or modified as we go forward. But with that said, Azure Synapse Analytics is wrong direction, excuse me, as a way of unifying this notion of big data analytics and traditional relational data warehousing. We start as a foundation from a technology perspective with the Azure Data Lake Store, what we refer to as, you may see it referred to as ADLS. So Azure Data Lake Storage or Azure Data Lake Store. And it's basically, if you think of, or if you're familiar with data lakes in Hadoop, or this idea of the HDFS or Hadoop distributed file system, it's basically a file system. It has evolved. If you're familiar, in the past, we had Azure Data Lake Store Gen 1. We've moved to what we call Gen 2. And the real difference was Azure Data Lake Storage was a separate environment previously. Azure Data Lake Store Gen 2 is now built on blob storage. So when you actually go to create an Azure Data Lake storage environment, you're going to go create a blob storage account, and then you're just going to, there's a checkbox in there. You'll flag that you want the hierarchical file system, which is essentially, on top of the blob storage, you get a hierarchical file system that allows you to apply the data lake storage patterns, or the data lake patterns, if you will. If you see on the right side of the slide here, we talk about this data lake integration with the common data model, or common data model aware. And this might be another area just to have a topic on, because it's evolving and growing and very interesting. And you think of this as something that Microsoft has come out with. There's a variety of scenarios. We have the Open Data Initiative, other efforts that we have going on with SAP and Adobe as an example. But the Common Data Model is an open platform for creating a schema or design of the data structure that you might have various different entities. It ties in very well with Dynamics as an example. And they have what they call the Common Data Service. So we can integrate that into the Common Data Model. When we say it's common data model aware, what the common data model does basically is stores data on blob storage or in the data lake store as CSVs, but then there's a schema file, a model file that will go along with that to describe that data. And Azure Synapse Analytics can look at that and understand that information. So if you're leveraging that from a variety of different places or reasons, such as maybe Dynamics or what have you, that allows us to snap directly into that. But that is the foundation, right? And we can apply security at that layer. And the Data Lake Store, and what we've done with Data Lake Storage Gen 2 and blob storage, it is optimized for an analytics pattern, right? When you think of questions may come up from a technical perspective, storing data at that layer, storing it in files. You look at why would I store in CSVs if I already have it stored in a relational data engine, as an example. But that's the design, that's the foundation of what we build upon. And you'll see why that becomes important here in just a few minutes as we look at the different types of compute that we can layer on top in order to really drive the patterns that we're after based on what business outcomes we're trying to drive. So I'm going the right way. So integrated platforms. Oh, go ahead.
Question about the common data model and the data lake integration. You mentioned that out of Dynamics and some of your other services, you're dropping files in the data lake as CSVs with a CSV, an additional CSV to define the schema. I know like Databricks is really, everything is, they recommend you store it as Parquet files because the schema is like in the file itself. Can you say anything about advantages to CSV with the CSV defined schema as opposed to like Parquet files?
Yeah, so I cannot speak to, because I don't know why the common data model as that format has chosen to use CSV as opposed to Parquet. Parquet is a compressed column file storage technique that we do use. You'll see, I'll show examples of using Parquet files in Azure Synapse Analytics. Parquet is sort of, I don't want to say, I might be going out on a limb a little bit to say it's becoming somewhat of a de facto file format for data lake storage, but it is highly optimized. We have optimizations in Azure Synapse Analytics for Parquet from a query perspective, as you see when we talk about the SQL on demand. Why the common data model is using CSVs versus other formats, because IoT Hub, as an example, uses Avro. There's a variety of other types of output formats that can be chosen. It just could be that it's just a universal, anything can read it type of format today. And if it evolves, I don't have any insight as to the direction there, but there are some techniques going in with optimized CSV access and so on. I would just believe it to be quite simply, it's just the most common denominator at this point.
Gotcha. And it's definitely parquet, like the butter.
That's how I say it. That's how I've heard it said, but I'm not a definitive expert on the pronunciation of some of these things. I'm still glad I'm not grappling with some of the zoo animals that we've had in years past. But yeah, thanks for the question. No, that's great. And it'd be great to dig into that. I think we have customers asking those sorts of questions when you look at, well, when you look at the data lake storage and structure, and I won't get into too much of it tonight, but there's various different formats. Databricks, you were talking about, some of the folks had some content from Databricks. They'll advocate the Delta Lake. There's some terminology out there that I'll reference. A colleague of mine has some blogs on this as well, where their Databricks will talk about the data lake house. So you think of kind of the evolution of the data lake and some of these other areas. I think we're maybe a little bit early from a technical perspective today. We don't, there's not the full integration with Databricks Delta Lake specifically with Azure Synapse. But again, as these things start to evolve, you look at that the Delta Lake in Databricks, and I don't want to get too far off track here, is trying to address one of the challenges with the data lake store, in that you can't do incremental updates, right? It's kind of like a, write once and read many type of scenarios. And then if you have incrementals, then you've got to parse that and kind of create that view that you're looking for. And they look at having basically a change log or changes and being able to create that Delta view for you. And there's different people have different beliefs on whether that is the data store for reporting and analytics, or is that just the intermediate and using Databricks as potentially as a data transformation layer for computer, for machine learning. But a lot of things are still kind of growing and evolving in that integration space there. Awesome. So we look at this as we bring everything together in an integrated platform. So we address scenarios such as management, security, monitoring. And one thing that's really interesting is the Metastore, and you'll see some of this as we come through here, what the Metastore does for us and how we can use that interchangeably between the two. And I will say, as we're progressing through the content here, it is important that to keep in mind, we're going to talk here, well, I'll just kind of jump right ahead because it shows up right here. We do have Spark in this environment, and very specifically, this is the open source Apache Spark engine. It is not Databricks. We do have Azure Databricks, and there's some discussion that we can have around the use cases for each. And it would be an advocate to say that Databricks, Azure Databricks specifically, has some great scenarios, and this is not in any way the notion that we should be moving away from Databricks. And there's different patterns or different scenarios or use cases that you might use Spark here versus Databricks, and others where you might use Databricks for maybe pre-processing or preparing data or the machine learning or what have you. And we have some great points of integration with Databricks, with ML, with our Azure ML offering, using ML Flow as an example, or some of these other pieces. So which direction you go is really going to be based on what your skill set is, for one, but more specifically, your scenarios or your use cases. But with that said, we have two engines, two runtimes, if you will. SQL. This is the MPP SQL Data Warehouse engine that we're familiar with from Azure SQL Data Warehouse, or if you're familiar with some of the on-premise, the APS, or what used to be the PDW, Parallel Data Warehouse, previously as an appliance that you could run, again, an MPP-based architecture, and then Apache Spark. So again, the idea here is you choose the analytics, you choose the engine based on what your specific needs are, whether it's SQL or Spark, right? Because again, bringing together SQL or EDW and the bringing together of the big data workloads where you might be wanting to use Python or Scala or something else. We'll get into some of the languages here in a moment for that data transformation or the machine learning, but then you might want to use SQL for, again, for your reporting and analytics, or it could be for your transformations. I know we work with many that use stored procedures and SQL to do their transformation, and we look at this pattern of ELT versus ETL, the notion of extract load, and you'll see a lot of advocacy for the extract load and transform pattern when you start looking at some of these big data directions, Azure Synapse Analytics as well, where you load the data, and that's really the pattern of the data lake. In contrast to a traditional enterprise data warehouse where you might do an ETL, you're going to do the transformation in the pipeline. You're going to load the data into a predefined or well-defined schema in your relational data warehouse that you've defined based on your business needs ahead of time, where the data lake, the whole idea of the data lake is you land the data raw. You land it as it is into a raw area, and then you go through, and there's various different terms. Some people call it raw and stage and refined as an example. There's like bronze and gold and so on to describe each of these. But the idea is that you would land it raw, transform it into the formats that you need, and you always have the source data, and you might have a need from a machine learning perspective to have somebody come in and explore that data in more of its raw format before some of the transformations have occurred that are well suited for, say, your business reporting or analytics and things like this downstream. So you have this choice now is what the idea is between Spark and SQL, depending on what the skill sets are. So you might have a data scientist or data engineer that prefers to be in Spark to do data transformation and exploration and experimentation. And you might have, your BI developer that prefers to be in SQL, or even a business user that can write SQL and want to have direct access to the data and go from there. So you have these two different engines. Then on top of that, we then provide different ways of actually running those and what we refer to as provisioned or on demand. So you can provision compute for SQL, let's say. We'll get into some of the terms here, what we would call a SQL pool, or an on-demand environment where you can actually run a SQL query and it just spins up the compute as you're running the query. And the costing and the model is different in those scenarios, but you don't have to instantiate compute ahead of time waiting for queries. You basically run the query and then the compute gets created to service that query. So there's that difference between the provisioned and on demand, both for SQL and for Spark.
Question on development tools?
Sorry?
Question on development tools.
Uh-huh.
In this environment, are the typical development tools for Azure SQL Data Warehouse Management Studio and for Spark VS Code, or are they different tools than that most people use?
Both. I do have some content on that coming up, but you can use you can use SSDT for SQL. You can use SSMS as well. We're going to talk about here. Let me just expand this out. You'll see we have this Synapse Studio, which is a web-based interface for this environment that people could develop in. But a common one as well is, so VS Code, yes, absolutely. Certainly from a cross-platform perspective. And if you're not familiar as well, Azure Data Studio or Azure Data Explorer. We keep changing the name on these things, but that's the query environment. I don't know to call it more dev environment. It's not quite SSMS-like, but it is sort of, I guess that's the right way of saying it. It's really SSMS-like, but it's not a direct replacement for SQL Server Management Studio. And essentially what that is an environment where you can write queries, and it's based on VS Code. It's based on the VS Code platform. So it's open source as well. So this came out when we came out with SQL for Linux. So now if you want to run an environment, and then there's add-ins. So it's an open source platform that you can write, other people can write add-ins for it. And we've got a variety of add-ins that can be used with it. So if that is something that the group hasn't really seen in depth, that might be an area we can explore in the future as well. But those are the common tools there. From a Spark perspective, it's typically notebooks that you would use. So again, we have a notebook experience that I'll show you here. It could be the notebook experience in VS Code, and Azure Data Studio has a notebook experience as well. And if you haven't seen it, if you like notebooks, you can do notebooks with SQL, which I think is really, really interesting. So if you want to do, your documentation and your code and have that to create a SQL notebook, I found to be, pretty interesting, especially from a, kind of training and perspective, and certainly development scenarios as well. But
where do you do that? The SQL notebooks, you do that in Synapse Analytics Studio or Management Studio, or where do you?
You could do that, but you can do them in Azure Data Studio.
Okay.
Let me just make sure that I keep saying this, and then I'm thinking, because I was using it before we released the actual final name. So yeah, it's Azure Data Studio. If you just do a search for it, if you haven't seen it, there's some documentation out there. There's an install for it. It updates pretty regularly. IntelliSense built in, a bunch of different scenarios. Again, there's a really great content out there. They're really advancing the product, and it's really, I find it to be really well done. You can't do everything that SSMS can do, but if you're looking for a cross-platform environment that you could do a lot of SSMS, and then with some of the add-ins, if you look at the add-ins, there's a bunch from Microsoft. There's some others that others individuals have written, or third party. I think Redgate might have an add-in or so in there to check out. But that's a great environment, and that has the notebook experience. They're really geared for if you're a SQL Server person, and you can use that against any of the SQL environments. Excellent. So then you have Azure Synapse Analytics Studio, which is a web-based experience, and we'll see what some of that looks like here as we progress through the evening. Oops, I'm clicking forward and I'm on the wrong screen. There we go. And as I mentioned, really bringing in that platform and unifying the management, security, monitoring, and this meta store, which you'll see here come relevant in a moment. As I mentioned, as we get started, there's a lot that we can talk about, that we can get into some details. We're going to touch on at a high level everything up to the Synapse link for Cosmos DB. What that is if you haven't seen I think it was a build that we announced this. What this is the ability of, without having to do data movement between Cosmos DB and Azure Synapse Analytics, you create a link, and then it exposes it, basically pushes the data, and you can query that directly out of Cosmos. So if you're looking for more of that real-time type of analytics on top of that data, that's what Synapse Links does. Pretty powerful, but I won't touch on that today. So what I'm going to do is I'm going to kind of take a step back here, drill into some of these different areas at a high level, and really kind of get you exposed to what's there. I got some great screenshots here, and then as appropriate, I got an environment up and running. We'll jump over there and take a look as well. So let me just quickly build this out. We want to talk a little bit about the Synapse Analytics, and we're going to talk about the studio experience. Now, as you go into Azure, you can search. You're going to find a few different Azure Synapse Analytics. One of them you'll see is, and I will say, so it's still in, a lot of this is still in preview. I probably should have started with this, forgive me, because if you go to Azure and you start looking for this, you're going to see something that says Azure Synapse Analytics, formerly SQL DW. So we say that Azure Synapse Analytics is it's available today, right? Because at the Ignite in 2019, we basically rebranded Azure SQL DW to Azure Synapse Analytics. So all of that functionality that was there then, that was GA or generally available, became Azure Synapse Analytics and continues to progress on. At that time, we had also released a handful of features that became GA at that time. Things like results like caching, materialized views, and some other pieces that we started to add in that became GA. So if you look at sort of the Azure nomenclature, if you will, you'll see things referred to as GA or generally available, or perhaps preview. So when you look in the portal, you may see Azure Synapse Analytics, specifically it'll probably be in parentheses like the workspace, and it'll say preview. That's really what I'm talking about here, but we do have customers currently running Azure SQL Data Warehouse that have evolved into Synapse, or if you were wanting to stand up that environment in a production sense, you have that because GA. The studio itself is in preview, and you can, it's in public preview, so you can use it and run it, but that's kind of on the roadmap for GA there. So let's talk through what this looks like, right? When we look at from a GA or from a Synapse perspective, the studio itself. So here's a screenshot of what the studio looks like. And again, you have this kind of splash screen. It's really nicely done. You've got some on the main page here, some things that you can access, some useful links, some common resources that you've used or recent resources, or maybe things that you've pinned depending on what you're working on. Again, it's all a web-based type of browser experience. And what you can think of is on the left side of the screen, we have these hubs, if you will, these activity hubs. You have the home screen, which is what I was just showing you. And then we have these other ones, or that home or overview there. We have this data, develop, orchestrate, which is actually changed in my instance called integrate, and then monitor and manage. And then these are the different paradigms that you work with inside of Synapse Studio to allow you to really navigate the various different components. So a couple of things on the top just to call out. We have updates. You can see some alerts or some notices that are coming up there through the notifications. You can change workspaces and even provide feedback. So I don't want to make a direct correlation, but there's some similarities to the Power BI experience. So if you've Power BI, if you've used Power BI, the service as an example, you see some of that same paradigm, the ability of quickly giving feedback, the ability of getting in that main splash screen, access to the blog and access to training and access to these other resources. So a similar paradigm. I don't want to say it's a direct mapping, but some nice things that have been done in that experience to really help you stay current, because the technology is evolving very quickly. It could be potentially challenging to do your day job and then try to keep up with the advancements on the functionality. It's great that it's all kind of being brought into here together. So as we look at this, again, a couple of things right out of the gate that you could look at, ingest, explore, analyze, and bring all that right from that splash screen. Or you can start to navigate some of the other pieces in the activity hub. The other thing you have is right inside of the overview hub, or that home screen, if you will. You have a new and a drop-down box. You see here on the slide, you can do a new script, a new notebook, data flow. These things will all become relevant more directly here over the next few minutes, but you have the ability right from here to say create a new SQL script versus having to go into, say, the develop hub and then create a script from there. But some nice little pieces to bring in. So now as we jump ahead, and we're just going to go through these sequentially here in this data hub. And the data hub is where you start to work with the variety of different data elements that you have. And there's a couple of pieces that you're going to have inside of this data hub. You're going to have pooled, and actually you'll see here when I show you my environment, the names have changed slightly. But you have these databases, you have tables, you have other artifacts in here in both SQL pooled. SQL pooled is the provisioned SQL data warehouse. The SQL on demand is that SQL on demand environment, and then Spark. What's nice is we can go back and forth between these environments where I could have a table in SQL, but I can create a Spark data frame out of that as an example. And then the link that you see on the right side, these are our storage accounts and data sets. Data sets are similar to Azure Data Factory. When we think of a data set there, it's a data set from that perspective. And then your storage accounts, you'll have a primary. This is the basis we saw on that previous screen, that foundation of the Azure Data Lake store. And then you'll have, you could bring in other data lake, or other storage accounts, other data lake accounts, or what have you. So if you want to work with other data that might be shared within your organization in a different data lake, you can connect to it and access it that way. But that's where you're seeing that linked environment there. Some nice things that you can do right from the browser in here. One is you can browse through the storage file systems. You'll see a little bit later, you can apply permissions right from here. You can see properties of files. You can preview the files. You see here the data lake, the account, the data lake store itself. You see the container, that's the file system. Again, follows the same paradigm if you're using blob storage or data lake stores in Azure today. You'll be familiar with these terms, but they're all visualized and manifest themselves inside of the environment as you would expect in working with that. Here you see there's a CSV file that we have as in a container in a storage account, and I can right click and I can preview that. There's a few other things I can do here, managing access, downloading the file. I can manipulate the file, like deleting it. I can create a new notebook from this file here, and then you see that preview on the right side of the screen. I can work with some of the properties here. You see the URL to the file and some other pieces that would describe what that file is, or if you want to control properties, you can do so from this environment as well. So it's not just a browsing environment, it's an interactive environment where you can manage this data that you would have in the data lake store, managing access, as I've just mentioned. Now, what's interesting is, and this is what's great as well, and you get to that on-demand piece, and I'll call out a few things, and if my mouse is coming through on the screen share, that'd be great. Because if you look on the first on the left, I can right-click, and I can say create a new SQL script, like you would say in Management Studio, and say select the top 100 rows. And what it's going to do, if you look in the upper right of this what's this call out here, is it's connecting to the SQL on-demand compute. It's doing a select top 100 from an open row set, and it's giving you the schema. It's picking all of that up, right? And here you see that Parquet file format. So it's going to do a query against that file, and then I can view that and do it all on demand. So the scenarios could well be, you're a data engineer, you want to see what's in this file, you don't want to create a table from here, you don't know what it looks like. Now you can start to quickly browse and see what's inside of this data. You could be a data scientist or a business user for that matter, exploring the data. You've got some analytics you want to do, and you want to start to explore the data that's inside of your repository that hasn't been already perhaps curated or loaded into a data warehouse with a well-defined schema. You're just going to base off the schema that you see here. And then in the lower right, you're seeing the same concept, but instead of doing a SQL, I'm doing a new notebook. So in this case, I'm creating a new notebook, and then you're seeing that being generated on the lower right. So that's what we're seeing here. That's the experience that we're seeing there. We also have the ability of doing a bulk upload into the SQL provisioned environment from that file. So if we wanted to load it, this is a newer capability to make it very easy to build that. Then you can create a stored procedure out of this if you want as well. And you see on the right side that script that it generates. So just moving on, touching on a few other points here, you can create an external table to that. So what's great about that is if you want to persist that definition, and maybe you want somebody to come in with a query tool or what have you, and query a table as opposed to trying to access the file in the file system right through the environment, through the studio, you can create an external table. So really, the idea here is we've got a variety of graphical ways of accessing the data in your data lake store, whether through browsing and exploration through query, or to create some schema definition that can be used by others downstream, and you can go from there. This is all using the SQL on demand, so it would not be uncommon to use this to say build a Power BI data model or an analysis services cube. If the only thing that your relational engine is doing is serving data to build cubes, then the SQL on demand could be a great way of doing it, because you're only going to query it when you need to populate the cube. You don't need to keep that compute running. So a couple of ways that you can bring all of that together.
So you would spin up a cluster or like call and instantiate that compute anytime you wanted to run queries like that?
Yes, so you don't even have to instantiate the compute. You just execute the query, and the back end it instantiates the compute, and then it's paid on the data volume, the data that you're querying, the rows.
How long does it take for the compute to come up?
It's pretty quick. I mean, I could show you some examples when we get to the live one. I'll show you an example of how that is, but it's really pretty instant.
Okay.
So it's not, it's the architecture in the back end isn't such that, well, we got to spin up a bunch of clusters and it's going to take like 5 or 6 minutes. It's basically like, it's just executing. There's a bunch of compute kind of just like that it runs against. And you're not paying for then to say, oh, give me a 32 core machine or give me 128 cores to run this. You're paying for what you're consuming in the data volume, right? So basically the rows, I believe it's the rows scanned that you're paying, that you're bringing that data back. So yeah, I'll show you what that example is now. And so now you start to look at the cost models, you start to look at the use cases, and if you have interactive queries where people are always hitting that, right? You probably want to have a SQL pooled, have the data provision there. You're probably going to have it in a column store, because this, now remember, this is going after the data lake store. It's going after either CSVs or Parquet files, so the response time may not be as fast for interactive queries a user would expect if you're doing Power BI, say, as a direct query, right? Then you definitely want a SQL pool. You definitely want to use column store indexes, results set caching, and these other things, right? If you're building a cube and it's running as an automated process in the middle of the night and it takes a little bit longer to pull that back, but you don't have to worry about what size compute you need. You don't have to worry about creating that, instantiating that compute, remembering or scheduling a job to shut it off when you're done. You just basically say, run this query, give me the results back. I run it one time through the evening, populate my cubes or my data, my Power BI data models or what have you, and then you're off to the races and you don't have to worry about it. So different use cases, different scenarios, depending on what it is you're trying to achieve, but giving you that flexibility. So, and then this is just, the screen's just showing you here what that would look like. Now you've got another table, external table that you could then reference in any like SQL view or any other way that you would access that. What this is showing is quickly, you can also do it over multiple files. So it doesn't have to be file by file, but you could do it after a folder. If you, multi-select a handful of files, it will then concatenate those together. And you see on the right, the SQL that it generates, it's bringing in all those files as a unified experience. So depending on how you're doing your data, you see this is labeled as part 000, 01, 01, 02, and so on. You might have it where you're loading it based on a day. You might have a single file for a day, and then you've got a week or a month, and you want to look at the whole month or what have you. You don't have to, pull in single files. And then this is kind of how it would look like, where you've got then tables, external tables, views, and so on for the SQL pool, SQL on demand, and Spark. And then I'll show you, keep track of time here. If we start to run out of time, I'll just jump over to the environment. You'll be able to see some of that directly yourself. And the databases here, load to data frame. What this is showing, which is really nice, and that's where that meta store comes in. I've got a table defined. In this case, I've got the New York Taxi predict table. It's a SQL table in my SQL pool, and I can right click, I can choose new notebook, and then from the new notebook, I can say, in this case, it's saying load to data frame, and it generates the notebook with the code from a Python perspective, in this case, in order to load that into a data frame in Spark that I would then either manipulate or query or do whatever I would do then in my notebook. So again, that shared metadata, if you created a definition from one or the other, you can go back and forth.
Is that Spark read SQL Analytics? I've never seen SQL Analytics as an option in that command. Is that a library that you guys have?
I do not know if it's something specific to us or specific to Spark.
Okay.
I would imagine it's a Spark environment. I'm not aware that we've done anything proprietary in the Spark environment that wouldn't be just open source Spark, but I don't know specifically on that particular library.
Okay.
All right. This is showing a data set. So this is a data set where we're using Azure Data Factory to move data in and or potentially out, showing you what that the properties would look like for that environment. So again, you have data sets in there as well. So storage accounts, databases, data sets. This looks slightly different. I'll show you in the actual environment here. So let's jump through the Develop Hub, because this is where a lot of the interesting work happens. You see it listed here: SQL scripts, notebooks, data flows, job definitions for Spark and Power BI. So the idea here is you can, again, develop your code, if you will, or your assets, whether they're SQL scripts, notebooks for Spark, and even Power BI. So you can build Power BI visualizations inside of the studio and then deploy them to your Power BI environment. So if you got Power BI Premium or if you got Power BI, however you're deploying and sharing your data sets and or visualizations, your reports and visuals inside Power BI, you can use this as an environment to build all of that. You don't have to. You can still use Power BI. You can use Power BI to directly connect to the Synapse environment, whether it's SQL on demand or the SQL pooled or what have you. But if you're looking for a unified, the idea of this is to streamline that experience. If you're looking for a unified environment where you can really bring everything together, you can do your Power BI right here and manage that with inside this environment.
Is the term that you're using data flows there, is that the Azure Data Factory data flow, or is that a Power BI data flow?
It is the mapping data flows from ADF.
Okay.
So the Power BI data flows, the Power Apps data flows, some of them have the wrangling data flow functionality. And this right now is, unless I missed an update, is specifically the mapping data flows, but it is that same ADF data flow. So what you're seeing here, when we talk about orchestrate, we talk about data flows, it is basically the Azure Data Factory. It's using the Azure Data Factory engine. And I don't want to misspeak to say that it's Azure Data Factory, because as ADF evolves, it may, not every feature may be directly inside of Synapse, right? As an example, the wrangling data flows are not here yet. Is my understanding that will be coming. I don't have any specifics as to when or how or what that's going to look like, but the idea is, if you, again, you want to have it unified, you can do ADF here, or those capabilities. You may have a need and desire to do Azure Data Factory independent of this. You may already have Azure Data Factory that you want to continue to use and run, and that's perfectly fine. And again, we continue to grow and continue to evolve. These are areas that we as these capabilities evolve, you may see differences as far as how that's being delivered.
Sure. Yeah, I was just asking because earlier you mentioned the common data model, and I'd often heard the common data model mentioned in the context of Power BI data flows, and so I was curious about that.
So yes, so very similar construct, but not identical between each of those, right? So yes, you can use Power BI data flows as an example to load data to the data lake, and the common data model is an example. So you're absolutely right there. And there's other ways of extracting or leveraging that data, but so very similar, right? Leveraging similar, same technology, but not necessarily exactly the same, right? So if you have a data flow in Power BI and say, oh, great, let me go to Azure Synapse Studio, or let me go to ADF, and I'm going to expect to see it to be exactly the same, it may not be. But so hopefully that kind of puts some clarity there.
Yes, thanks.
Awesome. So a few things that we have here from the develop script here. You have your new SQL script. You right click, and then you can create your new SQL from that environment there. So hopefully that it's maybe not coming quite clear from the slides, but it's you see the new SQL script, and then you have that script window create. You kind of run from there like you would in Management Studio or Azure Data Studio. Okay. Supports IntelliSense and so on. Now, the other thing that's nice, so now you can run your script. You see the script in the upper right corner. You can see it in the lower left, comes back as a table. You can export the results to a variety of different formats, but you can also view it as a chart right here inside of this this tool, this experience. And then here's the notebooks. So again, similar idea, allows you to write from a notebook perspective. Again, multiple languages, Python, Scala, .NET, Spark with C#, Spark SQL, which is different than T-SQL. So, and I didn't really mention earlier, but when we say SQL, I keep saying SQL for Azure Synapse. It is the T-SQL. And then here, just what we're calling out here specifically is that with your notebook experience, you have in the notebook this idea of configure session, and that's what you're seeing in that call out is you can configure like how big of an environment that you want to run in for that Spark session. And then here you're seeing the results, and then this just runs as a normal notebook, you know, with your text and the different cells of the code that you would run. I'm not going to go through all of this, just to highlight a few things. This is the data flows. So if you think of inside of Azure Synapse Analytics, you have data flows, which is your mapping data flows, your data transformations. And then you have the integrate, which is creating your pipelines, which is allowing you to build your workflow for executing various different tasks or components. So here's talking about some of the functionality from a data flows perspective, which is on the develop environment, right? The develop tab. And then where then later we'll see that we have the pipelines, and that's on that orchestrate environment. So here's a visualization of what the data flows look like. Again, these are the mapping data flows. You've generally, folks familiar with Azure Data Factory. I know that we talked a little, I heard as we were starting, you talking a little bit about integration services, that as well, that some of the data transformation scenarios. Have you used anyone used ADF?
I've used it, and I've worked with people who've used it. Be perfectly honest, I haven't yet met anybody who's a fan of it.
Okay. Well, it continues to evolve and improve, again, with the data flows, with the mapping data flows, the wrangling data flows. But this is showing you what that data flow would look like. And then Power BI, we've talked about this a little bit, so I'll go quickly here, but you do have the ability of creating your Power BI. It looks like that Power BI content creation right here inside the studio. And then you publish those out, you save those, and you publish those to the workspace in which you would like those reports to run. And then it's simply just, once you've aligned all of that, just simply save, and you're off to the races. And now talk a little bit, there's not that many slides left, so that we get to some of the interactive scenarios, but this is the Orchestrate Hub. You have a variety of activities that you can bring together, orchestrate together. The Synapse ones, you can run a notebook, you can run a Spark job, you can run a store procedure. The mapping data flows, leverage some of those, they leverage Spark under the covers. So you can coordinate the execution and activity here. You can move and transform. There's a copy command or run the data flow we were talking about. Maybe you want to execute machine learning. So it ties in with the batch processing or executing pipelines in Azure ML. So that you bring all this together through this orchestrate, in which you create the pipelines to execute the workflow. And the Monitor Hub here, you get to see some of the various different aspects, how the jobs are running, status, feedback on the jobs. And there's not much here. I'll show you in the tool a little more, but you can start to see the jobs. You see quick screenshot here, success or what have you in the execution of those particular jobs. SQL requests in this case, and Spark as well. And then under Manage Hub, you can manage the various different capabilities that you have here. So you can manage your pools, the Spark pools, the SQL pools, your link services, which is your definition of what you're connecting to from the orchestration perspective. Various different elements that would run the orchestrations as well, and security. And SQL pools, you can configure the scaling and or pausing of the pools themselves in that managed environment. Same thing with the Spark. And then this on the right side is referencing the uploading of packages. So we were asking about the SQL one for Spark before. Again, I believe that's open source Spark. I'm not 100% sure on that one, but if you, I've been asked this as well previously, if you had your own packages or things you wanted to run, you could, this is how you could load them into the environment if they weren't already loaded. And the link services I just mentioned, some of the data sources that we have there. Orchestration, running the orchestration. Your integration runtimes, these would be either self-hosted or your runtime. Again, think of it more from that Azure Data Factory perspective when you're connecting to various different data sources, either in Azure or outside of Azure for leveraging the self-hosted. Oops. And then permissions and maintaining control and permissions from that perspective. So from a tooling perspective, we touched on this, but just to kind of close the loop here, Synapse Studio, Azure Data Studio, SQL Server Management Studio as well. And then just for this one really brings it together, a variety of tools, Azure Synapse Analytics, Visual Studio, the SSDT environment as well, VS Code, Azure Data Studio, which again, based on VS Code, that same idea, fantastic tool. I really enjoy that tool, and then Management Studio as well.
So
Let's take a.
Can I ask a question about Visual Studio?
Yeah.
So I've typically done my database development work using Visual Studio and database projects. I've never developed an Azure SQL Data Warehouse. Is it the same tool set to do Azure SQL Data Warehouse using database projects, or is it a separate tool set?
That's the same.
Okay, so you can do a database project with an Azure SQL Data Warehouse in the same way that you do it within a SQL database.
That's my understanding. Yep.
Okay, thanks.
Yep. And it's the same in that if you notice here where it's got the target platform, right? When you bring in your project, and then like let's say you brought in a project from, and I haven't tried this myself, so I would, I'm going to maybe go out on a bit of a limb here, but I would expect it to work this way, in that let's say you ingested a schema from a SQL Server, and then you wanted to then publish that to a SQL Data Warehouse or Synapse, right? And now you may want to, there may be elements you have to refactor in here to determine how that's going to deploy, right? Because there's some elements in here that if you're going from one version to another, or previously I've used this where if you're coming from SQL Server and you're going to Azure SQL DB, when there wasn't quite parity, that would kind of allow you to go through there. I'm expecting that's the case here. I can't say that definitively because I haven't done it myself and I haven't read the docs to say that is the case, but and you would have to do it as a script as opposed to a DAC pack, right?
Gotcha.
But
and there's no upgrade tool that you're aware of where you can like migrate a SQL database to an Azure SQL DW?
there is not.
Okay.
And that's what I'm saying is there. Go ahead.
Sorry, I was going to change the subject slightly.
Oh, I was going to say there is not a migration or conversion tool to do that scenario. And that's where we've just come across this recently, and I haven't had an opportunity to test this out, but I want to explore that using SSDT in the way I just described would allow us to either determine or see if we need to refactor the code because certain elements may or may not translate the same way. I don't know that definitively, so it would be if anyone tries it and wants to give me feedback before I get a chance to try it out, that'd be great. But I believe that's the way that the SSDT would work.
The question I was going to ask is on Visual Studio Code. So I know it's evolving quickly. The notebooks thing wasn't, we had a good presentation on it last year, and the notebooks wasn't something that was presented. Whether it was available then, I don't know. Is Visual Studio Code, that you're aware, intended to become a developer tool in addition to like a DBA tool like Management Studio?
So VS Code is a code editing developer tool for sure, in my opinion. Azure Data Studio is the one with the notebooks for SQL.
Right.
And uh,
I misspoke. I meant is Azure Data Studio meant to become like a database development tool like Data Tools is, in addition to a DBA tool?
That's a great question. I can't speak definitively from a product direction, from the product engineering perspective, but there are various different elements you can do. And again, I haven't even tried this yet. There's so many new exciting things to come out to try that I thought in one of the most recent releases, they've added database projects to Azure Data Studio, similar to the way SSDT works, but I haven't tested it to see, does it behave exactly the same with the ability of refactoring and so on and so forth, or is it simply allowing you just to take in the schema as artifacts that you could then source control or what have you? So it has many of the elements of SSMS, for sure, not all of them, and more of them are growing. So it's very much a cross-platform or multi-platform administrative query writing tool. And I said with the most recent, or one of the most recent enhancements, I'd seen some updates to with this idea of projects, that there may be a bit of element of SSDT being brought in. I don't know that SSDT would be cross-platform, nor SSMS. So I would expect that anything we would do that would be, multi-platform would be in Azure Data Studio or potentially in VS Code. Now, VS Code has some of the management elements, and some of those elements as well. You got some SQL pieces in there, but I think there's more in Azure Data Studio. But I would say there's some more exploration, certainly on my part, to go through those various different components. And probably be great for the group to maybe peel that back a little bit to really understand those scenarios and that evolution. And if it's a matter of collecting feedback or questions that you have, this determined roadmap or direction, because I haven't seen anything specifically stated that it's going to be one or the other as far as like what have you, considering the existing tools that we have. And Management Studio continues to be updated and evolving as well.
Sure. Were you going to get into source control at some point for all of the Synapse stuff, or is that?
I wasn't going to talk about it tonight, no.
Okay.
But we certainly can if there's some interest by the group to get into more of these areas. And we kind of chatted last week about putting this session together. If we come away from tonight and say it'd be great to really explore Data Studio and whether it's Synapse and or multiple SQL footprints to apply it to, be happy to come back and discuss that and or get somebody to help with that dialogue. Or if it's, hey, let's take Synapse a little bit further into its integration from that perspective, and DevOps and these other things, data ops and DevOps for data projects are becoming more and more interesting to a variety of customers, as well as the monitoring aspects and the management side of it from that perspective, and tying in with log analytics and these things as it relates to Azure. But I was not going to cover that tonight.
Okay, thanks.
Absolutely. So let's see here. We got a few minutes. Not probably a ton of time to jump into a full-on demo, but let me just sort of escape the presentation here. And so let me bring this window in. This is an environment up and running. This is the Synapse Studio. If you're not seeing that on your screen, let me know. But this is what we have here. The Synapse workspace, again, very easy. Just because I'm live here in this environment, just want to highlight a few things. One thing that I thought is, if you start to explore this on your own, that's fairly, I think it's fairly interesting, is under help. And as I mentioned, that idea, if you're familiar with Power BI and the help, it's more than what we might think of from if you've used help in the past, or dare I say, date myself to say books online and kind of what was in there, right? You look at help and there's all these things like guided tours, certainly links to the documentation, which is being updated regularly, fantastic resource as well. But this knowledge center, I'm going to just explore this for a moment. because the Knowledge Center has some great learning resources. There's some samples in here. You could take a tour of the studio, use some samples if you want to have it load a data warehouse or database into the environment that you could, kind of test if you didn't have something already and you want to explore. But this browsing the gallery, I think, is really interesting because there's a bunch of data sets that are out here if you want to start to explore some of the different data to get exposure, get some comfort, get some hands-on to the environment. Some notebooks that are in here as well if you want to try these out, some SQL scripts, pipeline as well. So if you want to see what code looks like that people have generated in this environment, I think this is a fantastic resource. I just want to highlight that. But as we go through here, so I'll look at data. You're going to see some slight differences from what I had. I had some scripts open here as well. You see the databases, so you don't see that pooled or on demand. Here you see the Spark. I can tell by the icons that these are all on demand, and this is the pooled. My linked environments, I've got some different data sets in here, some blob stores, the data lake stores. If I were to look at, let's say, we've talked earlier about that on-demand piece. So let me just go find, I think this is a good container. So these are some Parquet files. If I were to just right-click on a file, say new script, say select top 100 rows, it's giving me the code here. I click run, and now it's giving me, it's running that. And again, pretty quick. I don't really know the size of each of these files, quite honestly, to say, these real large, what's your experience going to be. But when you look at that kind of spinning up and executing, you can see it connected to the built-in. So this is all the on-demand scenario here. So that's what that experience would be like. You'd be able to see that. Got some scripts that I've run here. This is just quickly, just to again show some of the performance and highlight here. So the size, you can see the number of rows that are coming back to count at least of the rows. And then this is that similar query. We're doing a little bit more complexity here and some joins. And you can see, again, this is running really rapidly going back. So again, this is just an example of showing scale and size. I think, since we have a few minutes left, I will address the question of Synapse versus SQL Server, SQL DB, hyperscale. They're different architectures, right? You have an SMP and then you have an MPP architecture. And we've seen examples where customers' experiences may not be what it's expected when you're coming right from SQL Server to Azure Synapse. Because they're different architectures, and we have to look at the patterns of query, and you have to look at the use cases and these other scenarios. And Synapse is a fantastic environment, very powerful tool. But if you're taking things that you've architected for SQL Server and over the years you've made it do what you want it to do, and then you just take it as it is without factoring that it's an MPP architecture and the way you do data distribution and these sorts of things like this, your experience may not be the same. So you just want to keep that in mind. And if you're looking for a quick lift and move to take advantage of what you have today, especially I think the comment earlier was maybe that the data size isn't so large, right? Because you think of MPP as a scale out. So it's designed for very large scale environments. And if you're very small, then column store and SQL DB with hyperscale could be a fantastic solution. So it really just depends on the scenario and use case, but both are great. It's just really a matter of what fits your specific needs. And we've seen examples with using SQL Server 2019 in a virtual machine running in Azure, potentially using Polybase connecting to the data lake store as an example, allowing you to get into that environment if you already have a data warehouse on SQL Server. And with some of the new things that we've done with the SQL IS extension, where you're getting many more paths like capabilities built into SQL Server running in a virtual machine, so giving you some great opportunity to migrate and progress there. So some great scenarios to think of, but we've got use cases where customers are using SQL in a virtual machine with existing data warehouse. It's more of a lift and shift and kind of gradually moving into the environment of the cloud in Azure and using the IS extension to get those benefits and leveraging the data lake even in that environment. And then moving, we've got examples where they're using SQL on demand and then moving into pools. So some great scenarios that really allow you the flexibility to choose what's right for your scenario or your use case. So that was kind of those things running there to show that in develop environment. I've got a bunch of SQL scripts here. I've got my Power BI, my data flows. If we want to take a look at, I don't think I have any open right now, what a data flow might look like. Again, you see those, various different elements in here. The notebooks. So again, these are notebooks built in here. Again, these would be your, for your Spark environment, the various different cells you have here that you would run. So very similar to what I was showing in the slides, but just so you can see what this looks like as you navigate through the environment. And then under that manage, I just did want to highlight that. Again, from that, here's your built-in, here's your SQL pool. I'm looking at the SQL pool. And then from here, I can scale if I want to scale up. Again, it's going to tell you your cost or what have you. If I want to scale this up to DW 2000, it's going to tell me my cost per hour, and then I can scale up and scale back, what have you. This is the pooled environment. We don't have those concepts for built-in or for serverless. And then we can also do similar types of things from controlling the resources on the Spark side as well. So we've got about 6 minutes or so left. I just keep talking about some of these things if you let me. So let me just pause here and see if there's other questions, or if this hit the mark of what you're looking for the level of content for tonight, and get some thoughts and answer any questions that you have. And then with that, I'm going to put up that last slide with some resources.
I have more questions, but I'll give other people a second.
So while folks are thinking of questions, or you can ask yours. There's an event coming up December 3rd from Microsoft, Shape Your Future with Azure Data and Analytics. I thought might be interesting that for folks to check out. Again, my contact information is back up there. And then James does a blog. James works in the MTC in New York. Does a lot of great writing. He actually spoke at the last PASS conference on this topic as well. And he's got a lot of great perspective in his blog around. I talked about the data lakehouse. I talked about some of the differences in his writings between SQL on demand. So wanted to call that out as well. The documentation is great. There's some demo videos and some other things you can get at through the documentation. So if you haven't gone to the docs pages, and then there's always MS Learn. I didn't put the link in here, but the Microsoft Learn site, there's some curriculum out there. It's all free that you have access to. Some great resources there as well. So
Nicole had posted a question, which I think Aaron might be interested in too, and I'm interested, which is, I've had random conversations with people over the last few years about when you get to a scale where you want to switch over to Azure SQL DB, because I know there's some overhead, right? There's more switches. You have to code things differently. You can't just lift and shift. So like some people have said, like there's advantages to Snowflake up until a certain size, like 10 gigabytes. But once you get above 10 gigabytes of data stored, you want to switch over to Azure SQL DW. Do you have a sense, based on your experience with Microsoft clients, when people frequently make that switch from a regular database to Azure SQL DW, like based on data size or other factors?
there have been various different elements of data size that I've seen. I don't know off the top of my head what the current documented guidance is. I've heard, I've worked with customers that have had a couple of terabytes and they've used Azure Synapse, and I've also had people say that 2 terabytes is too small. I've heard the number of 4 terabytes is kind of like a good demarcation. I will tell you that I think it has also to do, not only data size is relevant for sure, right? If you have less than a terabyte, my personal opinion would probably be is maybe it's maybe not the right direction. But it also is going to depend on your query patterns. It's going to depend on your use cases from that perspective. And if having the data distributed, and depending on what the queries are doing, and having that work parsed out, like you've got even let's say you have 4 terabytes and you're doing small little queries, right? may not be most optimal for the current architecture and an MPP-based approach. If you're doing large scans where you got to aggregate across all of the significant portion of that data and breaking it up in that way, it could be a fantastic use case or scenario. Now, the question of Snowflake is, I would submit it's a different paradigm, right? Because it's a SaaS offering, it's a kind of SaaS data warehousing. It's a matter of the way that it works and where the data is stored, and don't really. We can have another discussion around Snowflake and some of the merits there, what have you. If you're coming from SQL, I would submit that it may be more of, do you look at something like SQL DB or SQL MI as a destination, or versus say Snowflake, because Snowflake is a completely different paradigm. To say, do you go to Snowflake for a certain level and then go to say at Synapse? I think that's different, right? I think Snowflake would probably say they could handle, you wouldn't need Synapse, they could handle all of that. So I think it's a matter of, you're coming from a SQL environment, right? Do you go to something like SQL DB, SQL MI, and or Synapse, and then what are those scenarios or use cases that fit right for you? I think there's some evolution with Synapse. As an example, we've run into this recently where the merge statement is in preview right now for Synapse. So if you're doing ETL and you heavily rely on the merge statement, then that might be something that you hold off on moving to Synapse, right, until it becomes GA, perhaps, unless you vet out the way that behaves. And that might be something, again, I feel really comfortable with moving even SQL Server to an IaaS environment in Azure, starting, especially if you're new to Azure, starting to get the benefits of Azure, starting to see how the cloud works, because you're, as DBAs, and prior to Microsoft, I was a DBA, and we didn't worry about things like network configuration, as then. We were inside of a data center. We were typically behind a DMZ and firewalls. We had high speed bandwidth. I didn't have to worry about how do I give access to my environment? Do I have to be concerned about things that are more environmental in that scenario? So if you're a DBA that's new to Azure, moving to a VM where you might be more comfortable, or SQL DB where it's a little bit more in your familiarization, and then starting to get used to some of those other pieces as well, right? The foundations of Azure, and then moving to Synapse. And Synapse, you'd have that same thing as well with SQL DB, but there's some considerations there as well that I wouldn't want to go without looking. Now, we spend a lot of time with our counterparts on the infrastructure side, so I'm not suggesting necessarily that all DBAs need to become infrastructure and networking gurus and experts, but I think that it would be my opinion that as a DBA going to the cloud, having a little bit more knowledge and familiarization of some of those other components would be well served. That maybe as a DBA inside of a data center, that I had like glass walls and badges to get into and these sorts of things that I didn't, maybe incorrectly, I didn't worry because other people address that. Especially with your data. I don't know if that helps, if that's answering the question. And I just saw, based on your reference, thank you, Jeremiah, for the chat window. I saw the little flashing on the bottom, and I didn't have the chat window open. So let's see what we have here. At some point, can you compare Synapse to Databricks? I think I touched on a few of those. I don't know if I hit everything, and I will tell you quite frankly, some of this is going to be a personal perspective, right? Databricks is a fantastic tool for running Spark. Is it a EDW? They will position themselves as for query in many cases, and in some cases, it may be better relationally. I know Delta Lake is addressing some of the challenges there. I'm not sure personally. I'm not super deep in Delta Lake to say that it does or doesn't, but the use cases I've seen for Spark, specifically Databricks, historically up to this point have been for data manipulation, data transformation, that ELT type of approach, and machine learning. It's fantastic at those things. And then I've got some peers that will contrast that to say, well, if you're going to use Databricks, then you really need to know Python, right? Or you're going to learn Spark SQL, where if you're a SQL Server or SQL relational person and you know T-SQL and you're really great at it, you know, are you comfortable with learning something new? I'm always an advocate for learning new things, but maybe, you know, you would be productive continuing to advance your skills in that SQL. So I don't really have a strong opinion one way or the other. I think they're both great for the individual use cases that they may be best fit.
Nicole has a
Gallery.
scale out question related to nodes that I don't totally understand.
I guess started the orders.
It's at the bottom.
Had a feature of intranode query where the data within the same partition key was on the same node and the query was done on the nodes and then combined. Is that the case with Synapse? Yes, so it is a traditional MPP architecture in that sense. There's three ways of doing data distribution. There's a hash partition, there's a range partition, and then a replicated. So Nicole, in that scenario, the idea is to try to do as much work localized to the individual nodes themselves. And the work would occur there. Where the work doesn't occur, what happens is the data moves. So you'll get what's called a shuffle. So if you have, you know, node A, B, and C, let's say, and you've got data on A that is needed on B, well, the node's going to shuffle the data to B to resolve the query. But that's the way it works, is each node works on its own, gets its subset of results that goes back to the control node, which aggregates the results back to return back to the client. So at a general, and we might be getting a little bit deep here, and we're a bit over time. I can certainly go on, but want to be respectful for the group here. But just quickly, replicated tables copy the tables to every single node, and that's typically your dimension tables would do that. And then you might use a hash partition to more evenly distribute your data. And then in that case, your dimensions are local to the node, so that way you're reducing your data shuffle, and then your joins are occurring between that hash table and the replicated table. If you're using a range partition, because of the way the data skew might be and so on, same thing with the different techniques, that might cause the data shuffle. So I think the answer is yes, it does what you're thinking from an MPP perspective. And those are some of the tenets under the behind the scenes as to kind of how that works. Does that help or answer the question?
That's great.
Hopefully it doesn't create any more confusion.
No, thank you.
Awesome. Here, let me put my, since we're off here, let me stop sharing my screen. I think and then put my video back on so we can kind of say hello to everybody.
Is it possible to do a partial move to Azure SQL DW where you reference Azure SQL DB tables as external tables?
Great question. Say that again. You want to reference SQL database as external tables?
Yeah, let's say I start building out a data warehouse and it's going great, and then oh crap, I need to build a fact table with 50 billion rows. And I want to put that one fact table in Azure SQL Data Warehouse, but I don't want to move the whole thing. Can I put that one fact table in Azure SQL Data Warehouse and maybe a few related dimensions or something, and then use my existing data warehouse as external tables?
Yeah, it's a great question. I don't know. I've not tried that pattern. In theory, from a SQL 2019 perspective with Polybase, you would be able to do that. But as it relates to Azure Synapse, I don't know. I'd have to find out, and I can get back to the group and with an answer there. But I've not seen that pattern deployed. Whether it's technically feasible or not, I'd have to check.
I had a client that had that problem. They had a tiny data warehouse except for one table. They had one table that was insane. Everything else was normal.
And that was the fact table, I'm assuming?
There was one fact table for marketing that was just, it was 100 times as big as the entire rest of the data warehouse combined.
Yeah, and I mean, that might be an example where it would be good to move to Synapse. Now, if you're building a data warehouse where you have conformed dimensions and you're following more of a Kimball approach and you have, sort of multiple subject areas or fact tables and you want to keep that unified, yeah, it's a great scenario. I quite honestly don't know if it's technically feasible through the external tables in Synapse and or how it would execute. But no, it's a great question. I'll take a note on that and see if I can track down an answer and get a response back to the group. Other questions?
I was going to share something from the previous question about the data movement stuff. So a few years ago, I was actually utilizing the original PDW platform, and that was definitely something that took us quite a while just to wrap our head around that concept of how the data is distributed. And every once in a while, we would end up having some data skew issues where the data didn't really get distributed the way we thought it would get distributed. Or we had just made, we ended up having to rebuild it like 5-10 different times. But there's definitely some scenarios because we had made some errors at the beginning. It would end up being, an aggregated query where you're doing like an average or a group by or something like that. Ended up taking so much longer on the PDW than it would on just a traditional SQL Server. That was a challenge, just to have that different kind of a mindset on how to do your data model.
Yeah, absolutely. I mean, that's what I personally think that I don't know that there's certainly guidelines, right? I don't want to say that there isn't perspectives to say, oh, everything will work or not, but I think it really comes down to the scenario and understanding the workload, understanding the patterns, understanding are you architecting things correctly for that particular pattern, and taking advantage of that, right? I mean, we see two scenarios here where maybe the fact table is so large that a scale out MPP approach would be fantastic. And then another one where maybe a scale out MPP approach isn't that great because you have additional issues or additional design considerations such as data distribution, that if it's small enough, especially with column store and column store compression, you might just get what you need out of an SMP environment, right? So it's great. And I like the question about could you combine the two together if you have those specific needs, and I can, typically would say, maybe we would just say move the whole thing, but can certainly appreciate if you have a data warehouse with conformed dimensions, multiple subject areas, that, keeping then multiple sets of dimensions and multiple ETLs in sync could be perhaps, extra work that you wouldn't want to do.
Can you isolate a node and therefore kind of work around some of this?
You can. Yeah, you cannot isolate a node in Azure Synapse. You can scale up and scale down the environments, but you still have the data distributed. The compute scales independently of the data storage.
Yeah.
Cool.
Awesome. Well, hey,
no other questions? No. Sorry, go ahead, Mike.
No, I was going to say it's great that everybody stayed on and went way over. I appreciate the interest and the questions as well. It's been great to be with the group here tonight.